Okay, hey guys, sorry it was a little late this time, but we'll just get started. So we're going to be going over the introduction to geometry really quickly, so to help you on the math section of the SAT. Okay, so the first thing that you need to know is the type of geometric notation, or the type of notation that we use on the SAT, which is geometric notation for those specific questions. So geometric notation is used to describe lines, rays, points, angles, etc., just like, general shapes and stuff. And it might not be covered in your high school, so we're going to be going over it right now. And just give me like 1 second. Okay, we're good. Okay. So the first example of geometric notation is the creation of a line, segments, rays, etc. And if you give me 1 second, I'll just pull it up. So essentially, the first thing is that if you want to represent a line, what you would do is, let's say that I have a line like that, and then a line is infinite, so we draw little arrows here, and then point A is here and point B is here. So A and B. Now, if we want to represent that in geometric notation, we just do the same thing right above the letters. So the mouse is a little off, but it's right above those letters. Okay, so that's how you would represent a line. Now, another example is with rays. Or actually, let's talk about line segments first. So a line segment is just like a part of a line, but it ends at two distinct points. So, like again, this would be A, and this would be B. Now, this is a line segment, so what we would represent it as is, instead of drawing the little arrows like we did on the notation that we represented the line with, we just remove the arrows, because that means that this is a finite length, and it's it's a segment of a line. Now, the third important thing we're going to go over is rays. So rays are like a mix between a line segment and a line, in the sense that a ray has one definite point. So we'll call that A, or we'll call that B, and it stretches in one specific direction to infinity. So to remember that direction, we have like a reference point, so we'll call that C. Now, if we want to represent that here, we would do that. That's how you'd represent a ray. And you always want the arrow to be facing the direction that the reference point is in relation to B. So if C was like, on this side, then we would draw it like that, because C is to the right of B, but the ray is going to infinity in the direction of B. So that's essentially the main stuff. So yep, a unique line can be created by connecting any 2 points. So I can make a line, let's see. So let's say that I have these 2 bullet points. I can make a line with that. So that is a unique line. And then between any 2 points in a line, there is a midpoint that is halfway between the 2 points. So let's call that the midpoint. So what that means is this length and this length are both congruent. They're both equal in length. And that's an important concept to know. And then one more point that we need to know is that any 3 or more points may or may not fall on the same line. So if they do, then we say that they're collinear. So let's say that I have these 3 bullet points and they're on a line. So they are collinear. But if I didn't have 3 points, so let's say I had like 1, 2, and 3, there's no way I can make a line with that. So I have, let's say that the line went through these 2 points. I would say that these 2 points are collinear, but these 3 points can't be collinear. And instead, they're like coplanar, because they're on the same plane, but they can't be on the same line. Okay, now we're going to talk about angles really quickly. So there's different types of angles. So let's start with the basics. A straight line is always a 180-degree angle. So that's key. If you can't see the angle, it'll look something like that, sort of. And it's or not like that. It's not a square. It's a circle, or a semicircle. So it'll look sort of like that. And then that is 180 degrees because it is a perfect line and there's no like, crook in it. Now, if I wanted to see a 90-degree angle, I would just cut this in half, sort of, because a 180-degree angle is a straight line and a 90-degree angle is half of that. So what that means is you'll see this sort of, and this square represents that the angle is 90 degrees. And a 90-degree angle is important because it also means that the two lines are perpendicular, and we'll talk about that a little later. And then 45 degrees again is just you cut the 90-degree angle in half, and then you have this smaller angle, but it's still pretty recognizable. Now, supplementary angles are two angles that add up to 180 degrees. And in contrast, complementary angles are two angles that add up to 90 degrees. So let's talk about that. So let's say that I have let's call this a 30-degree angle. Or actually, let's say that I have a 30-degree angle right here. And then, okay, 30 degrees. And I need to find the supplement to it. Now, the simplest way to do that is to subtract the angle measure that I already have from 180 degrees, because that tells me the length of, or the angle measure that I need for the other angle to make them both add up to 180. So in this case, that would be 150 degrees. Because 150 plus 30 is 180. And complementary angles are sort of the same, but they're on a smaller scale. So for complementary angles, the difference is I want to find two angles that add up to 90 degrees, or a right angle, right? So let's say that I have let's call this a 5-degree angle, even though it's not, and I need to find the complement to that. What I would do is just subtract 5 degrees from 90, or 5 from 90, and I would get the answer that I wanted, which in this case is 85. So this value right here is 85 degrees. Okay, so when two lines intersect, the angles opposite of each other are equal in measure. So this is really important. So let's just draw an X, right? So this is a really important concept, because what this basically tells you is I have this problem, or I have this angle. Oh, sorry. I have two intersecting lines, and I have 4 different angles. But these two angles are the same, and these two angles on the left and right are the same. And you do that by drawing, like, it depends on the number of arcs that you represent the angle with to make sure, that they are the same. And this is an important concept because this is how you can prove congruency. And there's a lot of times when you have problems, for example, if I have 2 parallel lines or something like that, sorry. If I have 2 parallel lines and I have to figure out, like, let's say that they give me that this angle right here is, let's call that, I don't know, like 120 degrees. Okay, so I have to. Okay, so I have to figure out the measure of, let's say I have to figure out the measure for this, this, and this angle. Now, easily, because of the theorem we just talked about, these two angles are the same because they're two intersecting lines, right? So this angle right here is 120 degrees. Now, we already talked about supplementary and complementary angles. So this is a straight line. So what we can do is we just, we know that this total angle measure right here, sorry, one second. This total angle measure is 180 degrees. So because we know that this angle right here is 120, we just have to subtract 120 from 180, and we'll get the angle measure that this is, which is, 60 degrees. Okay, now let's move on to triangles. So first, the sum of 3 angles in any triangle is always 180 degrees. That's pretty explanatory. If you have 3 sides, then you can never go over 180 degrees. And in any triangle, the longest side is always opposite the biggest angle, and the shortest side is always opposite the smallest angle. So let's make this, like, let's make an illustration of this. So let's say that I make a triangle like this. It's a right triangle. Now, we know that this angle is the biggest because it's 90 degrees, and because a triangle has 180 degrees, no angle can be larger than 90 degrees, right? If one of the angles is already 90 degrees. So first, we know that this side is the biggest because this angle is the largest. And then let's say that this is 60 degrees, 60 degrees and 30 degrees. Now, because of the theorem we just talked about, this side right here would be the second longest. And then this side would be the shortest because the 30 degrees is the smallest angle in the triangle. And based on the theorem we just talked about, that would make this the smallest side. Because if you can only expand the distance between these, you can only expand the distance between these 2 points so much based on how large your angle measure is. The higher your angle measure is, the greater the distance between the 2 endpoints of the angle, which makes the length between them longer. So that's how you can remember that. Okay, so in an equilateral triangle, all the sides are the same length and all the angles are 60 degrees. So an equilateral triangle is a pretty special triangle. So all the angles are 60 degrees, right? So 60, 60, and 60. Now, because of the theorem we just talked about, you would think, oh, which side is larger, which side is smaller. But because all the angles are the same, all the side lengths are the same because it is, I could flip this triangle over or rotate it or whatever, and it will still look the same. So because all the angles are congruent, all the sides are congruent as well. And that's an important concept. All right. Types of triangles. So in an isosceles triangle, 2 of the 3 sides are the same length as each other, and 2 of the 3 angles are the same measures as each other. So I would have, so I have 2 angles, 1 and 2, and I have a third angle that looks a bit different. So I know that these 2 are similar because they're both angles connected to the base. And then I have a third, smaller angle that is not the same. And just on sight, this looks smaller. So what I know is that because these 2 angles are congruent, both of these sides are congruent as well. But I can't say the same for this side because the angle is not only smaller, it's just not the same as these 2, because that's the rule for an isosceles triangle. Okay, so a right triangle is a triangle that has one 90-degree angle as one of its 3 angles, and that's pretty important to know. So a 90-degree angle is represented with a square on the inside of the, sorry, one second. Okay, so it's represented on the inside of the triangle. Now, if I know that these 2 angles are 90, then I can't go over 90 for either of these angles. So that's how I know that this angle is the biggest. So the 90-degree angle is always opposite of the longest side. And then the other angles are just, it depends on the specifics of the triangle. Okay. Side length tricks. So if the angle measurements are 45, 45, and 90, then the side lengths have a ratio of 1, 1 square root of 2. So what does that mean? So let's say that I have a triangle sort of like this. Oh, sorry. Let's say I have a triangle like this, and I have a 90-degree angle here, and both of these angles are 45 degrees. Now, because these both are the same angle, I know that this side and this side are congruent. And they're in the ratio, just based on the Pythagorean theorem and rules like that, of 1 to 1. And then the hypotenuse is always going to be the square root of 2, or at least square root of 2 times one of the legs. In contrast, a different right triangle is the 30, 60, 90, which acts a little differently. So let's say that this is the 90-degree angle, and we'll call the 30-degree angle, and this is a 60-degree angle. Okay, so we know that this is the longest side, so we automatically know that this is going to be 2. And then because the 30-degree angle is the shortest angle, it'll have the shortest length, So this will be 1, and then all that's left is the square root of 3. Now remember, this doesn't mean that every 30, 60, 90 angle, or every 30, 60, 90 triangle has these exact angle or these exact side lengths. It just means that they're in the same ratio. So, you know, I could have a triangle that has 2, 4, and then 2 square roots of 3, or something like that. It just depends on the ratio, not the actual lengths. All right, Pythagorean theorem. So first, if you take the lengths of the two shorter sides or legs and square them and then add them together, the resulting amount is the square of the length of the longest side or the hypotenuse. So let's say, you know, let's call that A, B, and C. Okay, so simply put, if you take the length of this angle, or if you take the length of this side and square it, and then take the length of this side and square it, you will get the square of this side. So let's do a quick problem with that. Let's say that I have a triangle like this, and I have 3 and 4, and I need to find the hypotenuse length. Okay, so what I can do is square 3, which gives me 9, square 4, which gives me 16, and then add them together, so I get 25. Okay, that's key. Now, the important thing to remember is that this value is not the length of the hypotenuse. It is the length of the hypotenuse squared. So to get rid of that, you put a square root symbol over it and square root it. And the square root of 25, that's not supposed to happen, is 5. So I now know that that triangle has a hypotenuse of 5. Okay, so Pythagorean triples. Basically, a Pythagorean triple is just a set of 3 numbers that can be lengths of the sides of a right triangle. So if you know 2 of the lengths, you know the third using the trick. So memorizing these tricks can make solving the problems faster, but if you don't know them, you can still use the Pythagorean theorem. So common Pythagorean triples are 3, 4, 5, and 5. Or actually, so common Pythagorean triples are 3, 4, 5, and 5, 12, 13. Now remember that these are ratios, not the lengths themselves. Okay, triangle rules. So 2 triangles are similar if they have all the same angle measurements for each corresponding angle. So area equals base times height is one of them, and then in every triangle, the length of each side must be less than the sum of the lengths of the other side. So first, 2 triangles are similar triangles if they have all the same angle measurements for each corresponding angle. So basically, if I have 2 triangles that look kind of like that, and I know that these angle measures are the exact same, as in this angle measure is equivalent to this, and like vice versa for the rest of these, then I know that the sides are similar. They're not congruent, but they are similar. And what that means is that if you multiply all 3 side lengths of this triangle by some number, you will get the side lengths of this triangle. So basically, they just maintain the same ratio. Okay, so another formula is area equals base times height. That's pretty self-explanatory. Base is one leg, height is the other, and then you just divide by 2. So think about it almost like a rectangle, except you divide the rectangle by 2 to find the area. Okay, so in every triangle, the length of each side must be less than the sum of the lengths of the other side. So basically, the way that that'll work is, let's say that I have a length of like 10 and a length of 2. I have to have a value that is greater than 12 in order for me to make this triangle. Because if I had a value of just 12, then this would be a flat line. Or like if I had an angle of 10 right here, and then I had another length of 8, and then another length of 2, they couldn't meet. And if they did meet, they just fall on top of the 10 and make a straight line, which isn't good. because that's not a natural triangle. So the key is, if I have a triangle A, B, and C, right? Those are the three side lengths. The rule is A plus B is greater than C. B plus C is greater than A. And A plus C is greater than B. Okay, so that's about it for that. Parallelograms. So a parallelogram is a four-sided figure in which both pairs of opposite sides are parallel to each other. So basically, these two lines are parallel to each other, and these two lines are parallel to each other. Okay, so in a parallelogram, opposite angles are equal to each other, and the measures of all the angles add up together to equal 160. So this angle and this angle are the same, and this angle and this angle are the same. And if you add all of them together, you get 180 degrees. So that's pretty self-explanatory. So rectangles are special parallelograms because they have 90-degree angles for every single angle in the shape. So in a rectangle, if you know the lengths of the sides, you always know the length of the diagonal because you can just use Pythagorean theorem. Because if you split it down the middle, you get a 90-degree triangle. Oh, that's not where it's supposed to be. Okay, so in the rectangle right here, all angles are right angles. So if I have a width and a length, I just use Pythagorean theorem. So L squared plus W squared gives me D squared. Okay, so perimeter calculations. The perimeter is a sum of the lengths of the sides of the, any type of shape. So if I have a triangle, I would just add up all three sides. If I had a rectangle, I add up all four, etc., and so on. Now, the difference for a circle is that since it doesn't have any sides, we have to estimate it a different way using circumference, or using, determining the circumference, which is the perimeter of a circle. So to find the perimeter of a non-circular object, you just add up the lengths of the sides. But to find the circumference, which is the perimeter of the circle, you do 2 pi r, or 2 times the diameter, or 2 times the radius times pi. So let's say that I have a circle. Oh, that's not a circle. Let's say I have a circle and I have a radius of 2. And the radius is just any line, or the length of the line segment that extends from the center of the circle to any point on the outside of the circle. So let's say I have a radius of 2. To find the diameter of this, I would just say 2 times the radius times pi. So 2 times pi times 2, which is just 4 pi, and that's the circumference. So yep, that's just an example. Angle calculations. So the sum of the angle measurements of any polygon can be determined with a simple formula. So where S is the number of sides of a polygon, the sum of the angle measurements is S minus 2 times 180. So for example, a square has 4 sides, so the sum of its angle measurements can be given by 4 minus 2 times 180, which is equal to 360. Now, if you want to find the length of the individual angles, you do 360 over the number of sides, or you do the total angle measure over the number of sides you have. So in this case, it would be 4, and I would get 90. Now remember, all the angles are only congruent if you know that the shape is regular, which means that all the sides and all the angles are the same. Instead, I could have like some really weird octagon which has one really small angle and then like 7 much larger angles, and I would know what to do with that. Okay, so the tip for complicated problems is try to split up the shapes into shapes that you're familiar with. So, triangles or squares or something like that. So you might get a question that's like, what is the area, or what's the area of a lawn that looks sort of like that, right? So what I would do is just cut this into a triangle and a rectangle and calculate the areas individually. And that's basically how I would attack that problem. So the area of a rectangle is just length times width, and that's pretty simple. So the area is a space inside the rectangle. And if I have a rectangle which is width 2, length 5, I would just do length times width, which gives me 10, and that would be the area. And the area of a circle formula is just pi r squared. So we already talked about having a circle with a radius of 2. If I wanted to just find the area of that, I would just square 2 and multiply by pi. So I would get 4 pi. And that's basically the rest of the lesson. Okay, thanks for watching, guys.